Hello everyone, we are presenting on shared syllables for Amharic Tigrigna text-to-speech synthesis, and I am Lemlem. My colleagues are Meshesha, Atnafu, and Teferra. The outline of our presentation includes introduction, related works, statement of the problems, features of Amharic and Tigrigna language, experimentation, discussion of the results, and concluding remarks. Text-to-speech synthesis enables computers to convert arbitrary text into audible speech. Text-to-speech synthesis therefore undergoes a series of processes, among which text analysis and speech generation are the major ones. Text analysis is responsible for determining the underlying structure of sentences and phonemic composition of each word. The speech generation part, however, is concerned with synthesis of speech waveforms from the linguistic representation of the text. It's also responsible for phonetic realization of each phoneme. The speech synthesis part is also concerned with the selection and concatenation of appropriate speech units to generate speech waveform. Text-to-speech research has been pursued for the various languages in the world, mainly for English and most European and Asian languages. However, for the Ethiopian language, it is at its infancy stage. Having limited resources, both data and tools, the aim of this research is to explore the possibility of designing a bilingual text-to-speech synthesizer for Amharic and Tigrigna, which are the two most widely spoken Semitic language in Ethiopia. Previous researchers have attempted on this aspect, the aspect of generating speech out of text, mainly for Amharic, and one attempt for Tigrigna. The first attempt for Amharic was done by Line in 1999, and he made use of diphthong-based concatenative approach, and has reported that he's arrived at a good result, acceptable at its as starting or pioneering task. His result was promising and motivating for other researchers to go for it. Henok also pursued Amharic TTS with the addition of the time domain pitch synchronous overlap approach that makes the concatenative somehow smooth, and he also reported an acceptable result. Tesfaye attempted for Tigrigna using the same approach, that is diphthong-based concatenative approach, and lately Nado, Barakat, and Alula also pursued with Amharic TTS, and they have each come across different approaches. Like Nado has come through the formant-based approach, while Barakat has approached it with HMM-based synthesis, and they have reported promising and attractive results. Alula also took the task with the addition of non-standard words in the inclusion of the synthesis process for Amharic language, where the non-standard words are words that are having different forms of readings than the standard ones. And in all cases, they have got promising results, yet their attempt is seen to be focusing on monolingual approach. Thus, we have identified as a problem that given this language being under-resourced and many in number, more than 80 languages are there in Ethiopia, and the process of producing linguistic and acoustic resources is expensive and laborsome, we've attempted to identify common ground in related languages so that we minimize the redundancy of the costly effort, and we've tried to model Amharic Tigrigna bilingual text-to-speech synthesizer based on their shared syllables, basically consonant-vowel syllable overlap. When we investigate the features of Amharic and Tigrigna, they are both Idiosemitic languages, and they are members of the Afro-Asiatic language. And these two languages are the most widely spoken languages across the world, next to Arabic. And mainly in Ethiopia, they are the most widely spoken Idiosemitic languages. We've identified that Amharic and Tigrigna have consonant-vowel overlaps. In essence, each language has got some specific number of consonants and vowels, where Amharic has got 30 core consonantal segments and 3 labialized composite segments, together with 13 incomplete segments. And Tigrigna has got 32 consonantal segments that are core and 5 labialized composite consonantal segments, along with commonly shared 7 vowels across these two languages. Thus, we've identified 30 shared core consonantal segments and 3 labialized composite segments and 7 vowels across these two languages. The majority of these languages is composed of CV or consonant-vowel combination. Each character set is translatable to consonant and vowel combination. Even though most of their common syllables are CV, we have also identified that, we have also learned that CVC overlaps are there in these two languages. When I move to the experimentation part, we've tried to prepare the data required to model our bilingual TTS, and then we captured 2,000 sentences carefully from newspapers, 1,000 sentences for each language, and we have tried to analyze the overlap across these two languages so that the words that are composed of commonly shared syllables are to be utilized to be synthesized using multilingual speech synthesis framework, that is Festival. To this end, we're required to translate the Ethiopic script into the framework understandable format. Thus, we've gone through phonetic transcription. We've translated the Ethiopic script into consonant-vowel combination, and the observed variation between the Amharic and Tigrigna is as how the epenthesis is handled. There is more frequent use of the epenthesis vowel in Tigrigna than in Amharic, yet we've tried to translate both languages accordingly. In fact, we've translated the 6th order character in Amharic as a consonant because there are less use of epenthesis vowel in Amharic, and we have also translated the 6th order into consonant plus epenthesis vowel because there is a tendency to use more epenthesis in Tigrigna. Still, our assumption and our conclusion to go through such translation needed to be modified. This post-process was there in the insertion and deletion of epenthesis vowel in both languages. In Amharic, we needed to insert the epenthesis vowel in case of consonant clusters that are appearing more than 2. And in case of Tigrigna, we needed to delete the epenthesis vowel when the vowel is at a word final position. Finally, we identified the overlap. Based on our data, we found out that there was 70.5% overlap, CB label or consonant vowel label overlap. This is encouraging because even though it is a little bit below the actual overlap, given the data we prepared, this much overlap is attractive, and we also learned that the difference in usage of language in both languages, in Amharic and Tigrigna, one is using longer sentence and the other shorter. There is a variation in between these two languages. With in general, however, encouraging overlap between Amharic and Tigrigna. So given this overlap, we've tried to select words that contained the most frequent and shared syllables, and then we try to feed these words to the generic multilingual speech synthesizer, that is Festival. Accordingly, we've captured the speech output, and then the speech output is evaluated for its comprehensibility or intelligibility and for its naturalness using a 5-scale mean opinion score by bilingual speakers. The evaluators then rated the speech output to be acceptable in terms of intelligibility, as it's the register 3.09 of intelligibility most, and 2.08 for naturalness. The syllables are synthesized on generic multilingual speech synthesizer. Thus, the naturalness of the synthesized speech is somehow affected compared to the intelligibility of the synthesis result. This is because of the fact that the generic synthesizer lacks to map the inherent sounds represented in the syllables of the Ethiopic language. Furthermore, co-articulation effect of phonemes also affect the naturalness of the synthesized speech. To conclude, in this research, we have explored the consonant vowel syllables that are common for Amharic and Tigrigna, so that we build a bilingual text-to-speech synthesizer that optimizes resource, so by utilizing the shared aspects of related languages. The Amharic and Tigrigna share the same script or writing system, and a large portion of their CB syllables are common. To arrive at this, we've purposefully selected 2,000 sentences of Amharic and Tigrigna text from newspapers and analyzed the consonant vowel syllables of these two languages. Words containing the frequent syllables are selected so that we prepare data sets so that the syllables assume 3 different contexts. That is word initial, word medial, and word final contexts. The average performance of the synthesizer taking these 3 contexts is therefore found to be 3.09 for intelligibility and 2.08 for naturalness. The result shows that there is a variation of performance in relation to the position of the syllables, where performance in both intelligibility and naturalness is attained at word initial context, and less performance is registered for word medial context. The decrease in intelligibility and naturalness in the word medial syllables is attributed to the effect of the surrounding syllables, that is co-articulation effect. In general, however, the evaluation result indicates that intelligibility of synthetic speech is at acceptable level, that is above 3, above average, and naturalness needs to be improved so that it reaches to the average at least, by further investigating the signal level mappings of the unique sound in Amharic and Tigrigna, which is our next research direction. The research output can also be enhanced by transfer learning from resource languages. Yeah, thank you.